Hello everybody. Today's video is dealing with related rates and elasticity. So both of these are fairly interesting concepts. So let's go ahead and get right into it. So first we're going to be talking about related rates. So related rates are used when you want to know a rate of change for one variable based on another variable's rate of change over time. So up to this point, whenever we've been doing the derivative, we've been doing it with respect to a single variable. So if we're dealing with demand and price, we usually will be taking the derivative with respect to price. Now, it is possible, if time is not factored in, to still take our derivative with respect to price. So let's go and see how this works. So consider this example. If you're supplying MP3 players to a retailer, and you have the supply function given here, and assuming that retailer is selling the players for $40 a piece, but is planned to drop the price by $2 per month, well, how will this affect the number you supply? Well, very first thing, you take your derivative. But, as you would know here, we just took the derivative with respect to P, so with respect to our price. But we want it based on time. So what we could do instead is multiply by the derivative of price with respect to time, like this. Now, if you notice, dq over dp times dp over dt, well, the dp's on that side will cancel out-ish. So that gives us the equation dq over dt is equal to 0.2p times dp over dt plus 3 dp over dt. Now, we have a price of $40, and they're dropping the price by $2. So they're dropping it by per week, so that goes in the change in price per week. All right. Whereas price of 40, that just goes in directly for price. And that would give us an elasticity of negative 22 players per week. All right. Which means if they are dropping their price by $2 per month, we will be wanting to supply $22 players fewer. That should be per month. All right. All right, elasticity. So elasticity is talking about how likely something is going to change based off its change in price. So the demand of a product is called elastic if a change in the price has a large effect on its demand. So if I increase the price of my item by 1% and the demand drops by 50%, that's an insanely elastic price. So if you just pull and let go a little bit, it's going to go like crazy. So it's one like a really tight elastic. The demand is inelastic if a change in the price has a small effect on the demand. So let's say if I increase my price by 1% and like one person decides not to buy it anymore, that it would be an inelastic demand. Now, you can't really do this objectively, so there's actually an equation to use, which is this one here. So your elasticity is the negative of your derivative multiplied by your price over your quantity. All right. Now, if that is greater than 1, we classify it as elastic. If it's less than 1, it's inelastic. If it's 0, then it has unit elasticity. So the unit elasticity, that primarily means if I increase my price by 1%, I can expect my demand to go down 1%, and so on and so forth. All right. So if you use the same example of before, put those values in, and we'll find that it has a negative elasticity, which is less than 1. So it's a fairly inelastic equation. So yes, your demand's going down, but it's not going down by a ton, and based on the price that's changing. All right. First exercise. So the demand and price of your product can be multiplied by this equation here. And if you know that your current demand is 20 products per week, and you start increasing your price by $1 per week, see how much your demand is going to change. So go ahead and try this one. If you have a question, go ahead and check out the next step. All right, hopefully you've tried that out. And the very first thing you should probably do is put it into standard form. So we want quantity as function of price. Next, all right, take the derivative, and then we're multiplying it by dp over dt, so we get this equation here. Now, we do know that we are increasing our price by $1 per week, so dp dt is 1. So we get negative 4/3. All right, and then for your interpretation of this is that we can expect the demand to decrease by 1.33 units per week if the price change stays constant at going up by $1 per week. All right, so that was the related rate trial. Now let's look at an elasticity one. So it can be found that the fraction of children, Q, who attend a live concert where their family has a family annual income of X can be modeled by this equation here, where X is in $1,000. So find the elasticity of an income level of $30,000. Well, you have to use this equation. All right, go ahead and try from here. All right, hopefully you've done something. We're just taking the derivative. It's just a constant on the outside, so we don't have to worry about it too much. And you just take the derivative of the inside. All right, go from here if you need to. All right, hopefully you've done pretty well with that. So you just plug in 30 for all your X values. All right, hope you put those in. And you go and you get this value here. Now, interpretation. Well, it's less than 1, so it's inelastic again, because a slight change in the price or family income level doesn't change the demand a lot. So if you go up by $1,000 or down $1,000 in your annual family income, it's not going to change too much. All right, hopefully you learned something, and I'll see you in class.